Recently, your data center experienced a rapid expansion with the onboarding of a national banking chain. The footprint of the data center nearly doubled in size to support this new business. But 6 months after the expansion, there was a catastrophic failure of the main power supply in the new portion of the building. Auxiliary power was available, but it too had to undergo some modifications in order to adequately provide the amount of power needed for normal banking operations. This resulted in a 12-hour interruption of services at the data center and to the banking chain, costing both parties a great deal of problems, operationally and financially. Your C-suite had to overcome severe damage to its reputation, so they immediately hired a consulting firm to help them prevent this occurrence from repeating in the future. The consulting firm recommended that the data center add a temperature surveillance system to their existing condition-based maintenance program because of the criticality of the services the data center provides to its customers. The consultant and the data center's reliability team then performed a criticality analysis of the entire electrical infrastructure. Through this criticality analysis, they identified what components were most critical to normal operations, what components had the highest possibility of failure, and where the early warning signs of the mode of failure would be detectable with temperature sensors. The data center's management team then researched the different types of temperature monitoring systems available to them. The first type of system relies on hardwired single-point measurement. This requires a data hub to collect data, a power supply, communication source such as the internet, and one hardwire connection to each potential point of equipment failure that requires monitoring. In a single piece of switchgear, there could easily be 12 to 20 individual points of failure to monitor, making this a difficult and expensive task to implement. The next option is hardwired infrared camera and sensors. This system also requires a data hub to collect data, a power supply, and a communication source to transmit the data. The limitation of this system is the field of view for the infrared camera. The camera can only measure what it sees, and it is often difficult to mount cameras on compact equipment in a location that will see the targets. The third option is a wireless temperature monitoring system. This system is based on the fact that failing electrical connections produce heat, and the internal temperature of the panel where this connection is located will rise. This rise in temperature inside the enclosure can be compared to the outside ambient temperature, and the resulting difference, or delta T, between the two temperatures can be used as settings for an alarm to notify the maintenance team. Because the data center has many electrical targets to monitor, they decided against the hardwired single-point measurement system due to complexity and expense. Likewise, due to the many electrical targets to monitor, they decided against the hardwired infrared camera and sensors due to the exorbitant expense of the many cameras and sensors that would have to be installed. The team of executives and maintenance staff determined that a wireless temperature monitoring system for both the main and auxiliary power systems was the best choice. The wireless system was installed, and the maintenance team trained on how to select the appropriate alarm settings for their application. With constant temperature monitoring, the data center's C-suite is now confident that they will not encounter a future power outage due to power equipment overheating, protecting both operations and the company's financial well-being. Continuous monitoring of critical electrical assets enhances an existing condition-based maintenance program and alerts the maintenance team when temperature data is outside of predetermined limits. Cost-efficient wireless temperature monitoring is the smart option, since it does not require as much hardware, cabling, or expense as the other systems. The team's decision represents the importance of investing in uptime versus paying the expense of downtime.